Thanks a lot for invitation. Unfortunately, I cannot come this year to India, but I can give a 10-minute presentation about material and energetic utilization of biogenic waste and residues. You'll see a lot of names over there from the University of Rostock. Professor Morschek is attending in person. He's the moderator of this session. And you see the other experts of my team in Rostock and also at the DBFZ. This is the German Center for Biomass Research in Leipzig. I will talk about material and energetic utilization of biogenic waste and residues, especially in Germany, but also information about whole Europe, some general remarks about the circular bioeconomy we need for a climate neutral world, some information about the biogenic waste and residues, ecological challenges. A very important issue is the separate collection. From our point of view, a key for a sustainable solution in this area. The main technologies in Europe and also outside of Europe for biogenic waste is composting and anaerobic digestion. So I will give some information. And then also I will talk about mechanical biological treatment for residual waste and also mixed solid waste. It can be a good solution before you have a separate collection of bio-waste. Starting with this slide, some general remarks. We want to go to a climate neutral world, and therefore we need reduction, especially in the developed countries like Germany, of energy and also of material use. This must be half of the solution in the developed countries and the other 50%. Therefore, we need a 100% renewable energy system and a real circular economy and focusing on bio-based materials, a bioeconomy. Here you can see that biomass is a very limited resource. So we need first a lot of biomass for food. Then we have to use it as a material in a cascade way. And in all these fields, you have residues and biogenic waste. And therefore, you can also find a combination of material and energetic use at the end. Here you can see the biogenic waste and residues in Germany. We have roughly 240 million tons of dry matter. This is important. So the water is not counting here. It's real organic matter we have to handle. You see the biggest amount are coming from the agricultural and forestry area. And you see also below the municipal waste with large industrial residues and so on. This is the core waste management issues. You can see nearly half of it we can use afterwards for material and energetic use. And there we have to find the optimal way for Germany. And this is for all countries of the world and a big issue. That it is also an important ecological point you can see here. If you put all the greenhouse gas emissions together and compare it with countries or with big industrial sectors, you see in the comparing with countries, it's place 3. Before India, so nearly double of the greenhouse gas emissions from food loss and waste, comparing with all the emissions from India. So it is a big ecological issue. We need a bio-waste in a circle economy. This is a concept we have here in Europe, but we have to go a long way to implement all these issues you can see here on this slide. I will show you the Europe map, and the main result currently is that we have a big challenge for Europe because we have only 50% of the bio-waste is separate collected. The other 50% you find in the residual waste after the separation of bio-waste, and also we have, unfortunately, a lot of mixed solid waste all over Europe. In Germany, we started nearly 30 years ago with a separate collection of organic waste. Normally, we have a brown bin. There we collect the kitchen and the green waste. And this is important, very important to have a separate collection. We have a lot of advantages in this case because we have a reduction of the waste amount. In general, we have a better reduction of biological fraction in waste, can use it for a fertilizer. And on the right side, you see a lot of different advantages. I can't go in detail due to the limited time, but it's a key for a good use of the separate collected waste. Afterwards, you can compost it or go in biogas plants and produce a high quality compost and digestate. And also in the other case of landfilling and recycling of, for example, plastic, you have a lot of advantages if you separate the bio-waste before. So these are the solutions we have in Germany. As I mentioned, for the bio-waste, it's mainly composting and anaerobic digestion and mechanical biological treatment for the residual waste. I will come back to this point later. This is our concept in Germany. We have the organic waste from the households and this is gardening waste and also kitchen waste. In the cities, we have a lot of kitchen waste, and we can go first to a biogas plant and produce biogas. Afterwards, we have a second composting part, the green and gardening waste and park waste. There's a lot of wood inside, so this we can separate and use for biomass power plant, and the other part of the garden and park waste can go to compost. So we have different products, the biogas, we have compost and also electricity and heat from the biomass power plant. So this is a general concept we want to implement in Germany. On the biogas part, you can see here we have roughly 9,000 biogas plants, but only 250 are in the focus waste sector. The others are in the agricultural field. So we have nearly 1,000 bio-waste compost plants and only 250 biogas plants combined with this composting facilities. So there we have to increase. But you can see here we have a lot of biogas plant in general, and it's an important issue in the component in the energy system in Germany. But we need new concepts for the future. This is only a rough example where you can see that we can put out different products from the digester, have a decanter extraction, and produce chemicals for the basic of the chemical industry. And we have also the energy production with combined heat and power units, and can also produce good fertilizer. But therefore, once again, it's important to have a separate collection before. We have a high quality of our bio compost. There we have a quality management system that is working very well. So we have very low pollutant content. So this is not a problem. What we have right now is a problem of plastics in our bio waste. So this is also very important to have a high quality at the beginning. Afterwards, you need a lot of technologies we can manage, and we have the technologies, but it's increasing the costs, and this is not useful in general. Some words about the municipal waste in Europe. You can see here the development from 1995 to 2020. And so you can see also the main problem right now is that we more than 20% have direct landfilling. In Germany, it's forbidden since 2005. We have a slow increasing of the material recycling. We have increasing of composting and also incineration. But the main problem is the direct landfilling. And as I mentioned in the bio part, that we only collect 50% separately. This is the slide to this situation. If you have the left one, you can see the situation in Germany. In the Netherlands, it's nearly the same. We have a separate collection of different recycling waste streams, and after that we have a residual waste, and you can see here 40% is biogenic waste, and there we have to be better in the future to have a better separate collection, and we can use 5 million tons more for bio-waste composting or digestion. Mechanical biological treatment is one possibility to handle the residual waste, and 80% are going directly to the incineration. And in this slide, you can see the different possibility of MBT concepts. And this is the basic also for our international activities. A lot of countries need this step before the separate collection of bio-waste, and there we find also ecological, sensible and cheap version. Only 3 pictures from different suppliers in Germany. Here you can see some plans of Sutco treatment systems. We are cooperating with this company, working also in different countries in Asia. You can see here a very high facility with everything what's technical possible from Remondis. And there you have high level products, but it's also very expensive. And for food waste and commercial biological waste, and also for municipal solid waste, we have treatment systems of Titian. They are also working in different countries, more than 100 in general. So the last slide, we need in a global system, if we want to go to a climate neutral way, 100% renewable energy, and also a real circular economy. This is also focusing on bio waste, and therefore we need a separate collection. Germany is on track, but too slow, and we need the international cooperation, especially with the big countries like India, and I hope we can work closely together also in the next 20 years. Thanks a lot for the attention, and I hope you could hear me well.
Hi. Good morning. Are you hearing my voice?
Yes.
Okay. Hi, everybody. My name is Maria Mebrenza de Sarvestani, and from Italy. Good morning from Italy, and I'm so glad to attend the 13th International Conference on Sustainable Waste Management and Circular Economy. My name is Maria Mebrenza de Sarvestani, and my professor, supervisor, Professor Francesco Di Maria, from Department of Industrial Information Engineering, University of Perugia, Italy. Our research is about environmental consequences from the production of e-fuels, and e-fuels from integrated waste to energy and the electrolysis system, a case study in Italy. You can see, I want to share with you introduction, methodology, goal, scope, and system boundary, result, and the discussion. You can see to the introduction in the pursuit of sustainable further, and the mitigation climate change, the reduction of greenhouse gases emission is a paramount goals by using carbon dioxide emissions from waste to energy facilities and plants and feedstock, very important in the Europe and especially in Italy and for carbon negative energy source, but also contributed to the efficient recycling of waste carbon. In our goal to our research is about to study investigated environmental impact and indicated through the lens of life cycle assessment when capturing carbon dioxide emission from the waste to energy facilities and to reduce methanol and the liquid carbon dioxide from industrial purpose. First of all, I went to the proposed process description. As you can see to the methodology. The investigated scenario, you can see to the our study divided to base scenario and the integrated scenario. Base scenario is including the incineration unit, methanol production, and the distillate and the liquefaction, as you can see to the standalone, but integrated scenario. You can see to the incineration unit, absorption distribution unit, stripping and liquefaction, electrolysis, reactor unit, and distillation. You can see to the base scenario, the waste burning to incineration unit and the energy exists and heat electricity produced and outside, for example, company and another factory. And the integrated scenario, you can see the energy and the heat and the electricity because of the burning the waste, including the produce the energy and the electricity. And you can see to the best method for the capturing carbon dioxide here is absorbing and the stripping unit. You can see to the with monoethylene amine and electrolysis, you can see to the hydrogen and carbon dioxide entrance to reactor unit and the catalyst reactor in the type of the fixed bed reactor, and after distillation, raw material including methanol and water in separated, and CO2 capturing entrance to liquefaction unit and for applicant and industry. Okay, and this slide start a life cycle assessment including the goal scope, and I wanted to base scenario and integrated scenario impact categories and the life cycle inventory, assessment of impact, and the interpretation. Simulation work performance in the ISWMAW Pro 9403 and assessment of impact including method ILCD 2011 midpoint plus, and our goal assessment of impact including climate change, ozone depletion, human toxicity, acidification, and so on. For example, for a life cycle inventory, we need to inventory for ISWMAW Pro software. As you can see this slide, for example, for life cycle inventory absorption stripping for 1 kilogram carbon dioxide, as you can see, and the life cycle inventory for the production 1 kilogram liquid carbon dioxide from industrial process. For a start, the ISWMAW Pro, we need mass and energy balance, and for incineration unit, absorber stripping, electrolysis unit, and catalyst reactor, distillation unit, and liquefaction. And the mass output, you can see to this table, and the energy consumed. And the base scenario and integrated scenario, including to the system boundaries. Functional unit is defined in 1 ton methanol produced, and for base scenario, as you can see to the ecosphere, technosphere, and to the integrated scenario, the same. You can see the system boundaries. After we can use it the results, and for base scenario, impact indicator, and the characterization. In our study, we'll show to the global warming impetition and the PM, RD, and the FW. And this slide you can see to integrated scenario, and as you can see, for base scenario and integrated scenario. And as you can see to this slide, in this base scenario, return to previous slide, you can see to the figure D, related to primary contributed carbon dioxide equivalent emission of the production of liquid carbon dioxide, flow of the waste to energy process. Methanol production has the negligible impact. In the integrated scenario, in this slide, the monoethylene amine absorber unit has the largest contribution of carbon dioxide emission. The carbon dioxide captured by the monoethylene amine related to the sustainable reduction is emission from waste to energy, roughly the 60%. Overall, the integrated scenario resulted avoided emission of minus 492.3 kilograms CO2 equivalent per ton of methanol, and whereas the base scenario positive emission, as you can see, to the per ton of methanol. And in terms of particular matter and the PM, the integrated scenario, you can see to the this figure B showed a higher value compared to the base scenario. In both scenario, incineration representation significant contribution to particular matter emission. The monoethylene amine absorption unit in the integrated scenario contribution significantly to particular matter. And regarding to the freshwater exhaustivity and resource depletion, we observe the same extent of the impact the base and integrated scenario. However, there are notable differences in the contribution each individual process, particularly when excluding the incineration. You can see to the conclusion in our study. Our study in crucial and investigated two scenario and the base scenario and integrated scenario for methanol production. In the base scenario, emissions were primarily deriving by liquid carbon dioxide production and waste to energy. Also methanol production, minimal impact. Result depletion assessment highlighted to varying impact of different process, and integrated scenario slightly lower overall resource depletion impact. The absorption unit remained a sustainable factor, and in this our conclusion to our study, as you can see. Thank you for your attention. And if you had any problem and any question, is it free for contact with me and my professor, supervisor, Professor Francesca Di Mario from University of Perugia, Italy. Thank you very much.
Okay, now you can see me, but the problem is that you can't hear me. Now we try it once again. Waste is not a source for a product. Waste is just the source for the energy. Yes?
Do you know about the source of the material for your incineration, or I don't understand? Can you repeat again? Because your voice not good and not received.
No, the question is you don't use waste as a source for a product. You just use waste as a source for and to produce energy for your process. Yes?
Yes. And for base scenario and integrated scenario, for base scenario, we not use it to ensure the electricity and the energy. And the integrated scenario, for incineration unit, burning the waste and produce energy and electricity. But if you have a problem, can you want me again explain to you?
No. I think we should stop it because we have more presentations. But I think in this case, the energy comes from the waste, and waste was not raw material. Okay, it's just how we always use energy from waste. Okay.
Yeah.
Then
Energy.
thank you very much.
You're welcome. You're welcome. Thank you very much for your attention. I'm so glad to attend, and I hope soon the next week attend to the conference. Have a nice conference and have a good time.
Thank you very much.
Bye.
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 Is there people from Hungary? The next presenter from Hungary?
Hello, good morning. Good morning, everyone. I'm Attila Kalman from Hungary, and today I will speak about methodology for life cycle assessment of blue-green infrastructures in a green city development program. Just a short notice: blue and green comes from blue is the water, the rainwater. Green is basically the nature-based solutions, the plants and the green areas. So, where does water come from? Water is in the hydrosphere. Probably you all know it. It's circulating all around the Earth. It's in different states, in vapor, in liquid, or in ice. And the hydrosphere is a quasi-closed system, meaning that water is not created nor disappearing. So it's just moving from one place to another, one state to another. Therefore, it's very important that we should keep and protect this resource, because water is one of the most important natural resources that we have. Basically, this is essential for everyday life. We claimed it as a renewable resource, but as we pollute, it's getting harder and harder to get it renewed. So sometimes we feel when it gets dirty and polluted, it's not renewable, or we need a lot of energy and technology to make it again reusable. But the question is always that what is the value of the water, or what is the cost of this renewable process? Of course, we know it's very different. When we are in the desert and we would like to get one glass of water, we would pay a lot of money for that. But when we are swimming in the ocean, for another glass of water in the ocean to swim, it doesn't cost too much. So we have to figure out the good variation, the circulation of water, and to maintain the renewable state of the water. We have to develop in a sustainable way, which has three basic pillars: the environmental, the social, and the economic. And these three pillars of sustainable development should be balanced. If they are unbalanced, we would live in cities like the one in the example, when we are just focusing mainly on the profit and the economic. But probably most of us would like to live in cities which are shown in the picture on the bottom right. So there was a development program in Hungary in the past few years, which was aimed to develop green city centers. And the aim of the program was to develop to enhance biodiversity, green infrastructures, social awareness, better air quality. And actually, the participation rate was very high. There are 346 cities in Hungary, and more than 57% participated this project. So I believe it's a very big number. And the aim was to become climate-friendly cities. The average project size was about $1.2 million. Of course, the project sizes varied. There were small projects with a few $100,000, and there were large projects for 5-6 million euros. As you can see in the picture here, this pie area shows the amount of the values of the different projects. This is just one part of the Hungary. We have 8 regions. This is one region, and just for you to see it better, I highlighted one county. And here you can see on the right the project sizes with the different pie diameters, and also with the different colors. I showed you the different areas that were involved actually in the real development programs. You see that biodiversity, green infrastructure, energy investment, transport development were pretty much in each project. And about half of the project included water management or water-related issues. I believe it's a bit low in case of a green city program, but let's see the results. So we speak about green cities, and the question is, are they really becoming green? Of course, when we look at the original state and when we look at the final state, we see that, oh yes, cities are getting greener, and instead of the gray areas, we have trees, grass, and it looks like a bit green. But on the other hand, the problem is that they are not really getting greener in the sense of environment, because as you see, water-related issues were categorized into 8 subcategories, and most of the developments only contained 1 or 2, so basically very few water-related issues. And even there were cities, this is just for one country example, but it was the same all around Hungary, that some of the cities didn't even include any water-related issues. Why is that a problem? As we looked at into details, it caused 2 really main problems. One is from the monetary issue, as the cost of irrigation. When we speak about green cities, we believe that there should be plants, trees, and green areas, but all those green areas need irrigation. Irrigation has costs, especially as we go into the climate change and summers are getting warmer and with less precipitation, the irrigation cost is going to increase. So if we would like to solve the problem with tap water irrigation, as we are not collecting rainwater, for this one county, the annual cost is almost $19,000 just to water and keep these areas green. It's for the lifetime, almost $500,000. This is just one part. This is the economic part. But on the other part, we also have the greenhouse gas problem, because just watering the plants or the area and keeping it or maintaining it as a green city, the use of tap water from the water treatment plant, from the distribution system, from the extraction, a lot of carbon dioxide is emitted. So basically for these few cities highlighted in this county, it's 7.5 tons carbon dioxide annually, which is 376,000 carbon dioxide for the life cycle. If you look for the country as well, you see that it's almost 10,000 tons of carbon dioxide, just because we are not using rainwater, we are not retaining in nature-based solution. So, and we use tap water. So what is the problem? Basically, the problem arises already with the planning phase. That public awareness and stakeholders are not involved in the development phase or the pre-development or pre-assessment phase. So it should be supported, or it should be included in the development programs. The other one is that the land use is not really taken into consideration. And also the other problem is that the engineering part and the economic part and also the environment parts are not really balanced in these development programs. So the solution would be a sort of optimization between the economic and the environmental part, also with the use of the engineering designing phase. So with the sustainable development, we should find the trade-off between the costs and the environment effects of the carbon dioxide emission and also the water retention use. So basically it should be a circular design. So once we have the pre-assessment, we should go back and reassess and redesign the land use or the projects themselves, and then do the developments. So this is what I wanted to briefly introduce you today. Thank you for your attention. I hope I got back to schedule. So if you have any questions, please let me know. Thank you for your attention.
Thank you very much for that. And we have to wait for the end. I think the next presenter is also from Germany. Okay, Mr. Endel.
Yep. Hello, Gerd.
Okay, please.
Good morning, everyone, and please welcome to my presentation. My name is Tommy Ender. I'm a PhD student and scientist from the University of Rostock in Germany, Department of Waste and Resource Management. So the topic of my presentation is the hydrothermal carbonization of the organic fine fraction from mechanical biological treatment of municipal solid waste. So here you can see my topics. At first, I want to introduce you into my topic, and after that, I would like to explain why we want to use HTC as an utilization way for municipal solid waste. And after that, I would like to introduce you into the hydrothermal carbonization technology, and after that we would like to introduce you into the material and methods and also share with you my results, and then go on to the discussion and conclusion. Okay, well, here in Germany we have a prohibition of the direct landfilling of municipal solid waste since 2005. Because of that, we have to instead looking for alternative treatment ways, or we have to pre-treat it, the waste. So one possibility is incineration, but another possibility for the treatment of municipal solid waste here in Germany is the so-called mechanical biological treatment, MBT. So this is a combination of various technologies, where first the non-recyclable materials are divided from separated, and the so-called biodegradable fractions, we could use or convert them into inert stable components by using the composting or anaerobic technologies, anaerobic treatment. So that is a way to convert these so-called organic materials from the municipal solid waste into stable components by using composting or anaerobic technologies. And then after that, with this pre-treatment, the final products can then be disposed in landfill with landfilling or an incineration plants. But instead of that, we wanted to have we had another idea to convert the organic fine fraction from municipal solid waste instead of using the composting or using the anaerobic treatment. So our aim was to convert the organic components into another valuable product that we can use for other options like landfill or incineration. So because of that, our idea was to study it with HTC. And HTC is a promising technology of the conversion of municipal and industrial organic waste into useful products. With HTC, it's like, how to explain? Imagine a big steam pressure cooker. So we have high temperatures and pressures. Temperatures like 180 up to 280 degrees and high pressures, of course. And the HTC, the hydrothermal carbonization, is a thermochemical conversion process that is especially positioned for waste or moisture biomasses like seaweed sludge or beet pulp or brewer's spent grain. But instead of that, we wanted to test it with the organic fine fraction from municipal solid waste instead. So here in the figure 2, you can see our HTC reactor we have here in Rostock at our Department of Waste and Resource Management. And figure 3 would like to show you the main aim of our experiments. So at the left side, you will see the organic fine fraction from municipal solid waste we collected from a waste treatment. After that, we wanted to convert the organic fine fraction by using the HTC, the hydrothermal carbonization, into a hydrosha on one side, which is a lignin-like coal, and on the other side is so-called process water. So after the HTC experiments, there's a solid-liquid separation. We just did it easily by using a so-called Büchner funnel to separate it into the both fractions. The hydrosha, which is a coal like lignin-like coal, and of course the process water. Yeah, we took some samples. We took 3 samples. You can see the samples in figure number 3, and of course you will see here all analysis. We did a quick pre-analysis of the samples, like the moisture content, the dry matter content, the organic dry matter content, the ash content, and of course the caloric values, the higher heating value you see here. So nearly in the mean, the sample has a moisture content of 42% and dry matter of 53% and 32% of ash. Anyway, here you can see our experimental conditions. Figure number 5 shows our HTC reactor at the department. It has a volume of 1 liter, and for our experiments with organic fine fraction, we use several temperatures and several retention times, reaction times. So at first, we decided to make the experiments with looking into the literature and compare it with other studies with temperatures of 200 degrees and 220 degrees with a retention time of 30 minutes and 120 minutes. So after the pre-trails, we decided to increase the temperature for the main trails up to 230 degrees and 240 degrees because of the results. But anyway, we decided to let the retention time with 30 minutes and with 230 and 240 degrees. We decided to let the retention time of 2 hours, 120 minutes. So after the experiment, there was a dewatering with a Büchner funnel. You can see the dewatering in figure number 6. And we get some interesting results of the hydrothermal carbonization of the organic fine fraction from municipal solid waste. You see in table number 5 on top that the ash content increases and the fixed carbon decreases, and also the higher heating value is a little bit curious. That are interesting results for us, and especially also the process water is interesting because we know from HTC that the process water is mostly acidic, and normally the process water has a high content of COD and CO2. But I guess it's because the short reaction volume, that the processed water has a not so high COD content, as you see in table number 6 on the bottom. And also the TOC, the so-called total organic carbon content of the processed water, is nearly low, while and on the other side, the phenols are also interesting in the processed water because the input material was something else like sewage sludge or brewer's spent grain or beet pulp, because it was a complete new substance, a complete new input material for us to to have experiments with it with HTC. So the results anyway are that with municipal solid waste with dry matter content of 20%, which we both have experiments of 200 and 220 degrees, we have a residence time of 30 and 120 minutes, and the results shows us that the caloric value and the carbon content of the hydrochar at temperatures of 200 degrees is much lower than the input material, but at 220 degrees it was much higher than 200 degrees. So this is interesting for us because with the value of other important parameters for the quality of the hydrochar showed that the time has no significant influence instead of the reaction temperature. So we found out that it played a key role because increasing the temperature in a certain time had a positive effect to lead to notable changes. And for example, the amount of fixed carbon in the hydrochar increased significantly compared to before, and that's very interesting with the hydrothermal carbonization as a valorization technology for the organic fine fraction from municipal solid waste. So anyway, I think my 11 minutes are now over, so I come to the discussion and conclusion. So we found out that the most positive effect was when we operated with 20% of dry matter and with the temperature. So we found out that at 220 degrees for 2 hours, it has a greater, higher energy content instead the other experiments. So, however, an increased proportion of garden waste in the waste residue affects to the fuel characteristics of the hydrochar we gained. So, whereas the pre-treatment phase of the MPT contributes to reducing the organic load of processed water. So this is maybe our theory, while the COD and the TOC content of the processed water are so low. Yeah, anyway, thank you very much for your attention. If you have any questions, please don't hesitate to write me. You can write me here in my email address. And it was a pleasure for me to attend here at the conference. So thank you very much.
Yes, thank you.
My name is Dirk Hartl, and I'm obviously not the first German one. And I was thinking about when we having a German chair of the session and also some other German presentations, we might switch to German, but I think it was a good idea, so I'm coming back. Yeah, thanks a lot. So I'm coming back to English. My name is Dirk Hartl. I'm a professor of logistics and supply chain management at the ISWMAW in Stuttgart. It's the capital of the state of Baden-Württemberg in southwestern Germany. And I want to present you the paper called Application of Artificial Intelligence in Supply Chain Project Management, Insights from German Organizations. So you clearly see that it's a quite different topic I'm talking about. I'm coming more from the perspective of business management, but I'm very happy to be here and to have the chance to talk to you. And by the way, DHBW is also for several years a partner university of ISWMAW. So thanks for joining, be it in physical or be it online. So Research was not just conducted by me, but also of a dear colleague of mine, Professor Öncü Hazir. He's from the Business Rent School, and he's associate professor of supply chain management. But he wants to send his apologies, so he's not able to attend. So it's up to me to present it on my own. So, what is the topic about? If you talk about AI and supply chain management, you might think, okay, there's a rising number of publications regarding this topic. That's really true, I must say. So, especially within the last 3-4 years, we see that development quite clearly. But we also see that from the perspective of supply chain management, the role of projects, they day by day, not only in the VUCA world, more and more important role in this situation and in the work life of the manager of the supply chain management, or for example, as a logistics manager. And we also see that in that case, the responsibility and the expertise is more and more relevant to get those, to use the possibilities of AI when doing supply chain management. So what was the baseline? We had 2 areas. The one was coming from the general project management side, and the other thing, the other area was about talking about supply chain management and the application of AI in general daily business supply chain management. For example, how to handle the communication, for example, or the data management within your company to organize the right quantities from A to B. So due to the lack of time, I just want to point out regarding literature review 2 aspects. One is that it's although there's a huge number of publications within the last years, we see that it's a very modern research discipline. So we found out, based on our literature review we conducted before, that I would say more than 90% of the publications were published just within the last 2 or 3 years. And just to summarize it, I want to cite here Wei et al. 2021. They reviewed several papers and they found out both connecting supply chain management and project management. And they note that even though both areas have common research streams, only a few studies work on integrating supply chain management in project management. So the topic is how does AI methods could improve supply chain project management. That's the topic about it. So what was the methodology? It was based on a qualitative approach. So we had interviews with 14 supply chain managers, all of them practitioners with an academic background. That's quite clear. And it was conducted at the beginning of this year, and it was conducted online because most of them, they have, or all of them, they have a working place in Germany, but most of them not in the region of Stuttgart. So two things were relevant to us. One thing is we need supply chain managers to have a certain kind of experience. We found out at the minimum level of 4 years, and at the same time they also should have some project management experience. So it's also at the minimum level of 4 years up to 14 years. So we decided not only to focus on the automotive industry, because maybe you might think of Stuttgart, you might think of Mercedes-Benz, you might think of Porsche, you might think of Bosch, but nevertheless, we decided to have a broad perspective, a more broad perspective. So what were the general findings? What did we find out in general? I think it was a little bit sobering, to be honest. That only 3 out of 14 experts have first experiences with AI methods in supply chain project management. Almost all of them told me, yes, we got experience with AI, using different kinds of machine learning, something like that, or big data approaches, but only in general business, not focusing in their project management. So the next question was quite clear. What were the reasons behind it? And I think without mentioning all of them, I would like to stress the following two. The one thing is time pressure, and also I think it's a little bit combined, the missing knowledge. So supply chain managers, although being very experienced, they didn't know how to use AI methods in a certain type of projects they could apply it on. And as you might remember, the topic of the paper is about German organizations. We also found out that there are some specialities. I said all of them have a working place in Germany, but all of them also have some international experiences. For example, they found out, okay, the aspects of data protection, that's a really cool, critical issue in Germany, data protection, personal data. I think we are very different to the Chinese people or the US colleagues of our data protection is a very important issue for us, especially if you talk about big data. Is there the option to get personal information? And that's not only due to the work council, a big issue for any supply chain manager or a project manager in that. So let's just come over to point out some results, because the interview was also based on different phases of project management and the definition of PMI. And the first one was, okay, what about the potential use of AI in project phase initiation? So what could be the potential use? We were already always talking about potential use. As you might remember, that most of them haven't had any real experiences in project management and AI. And I think I just want to talk about one point. It's about the suggestion of new supply chain projects, supply chain management projects. So how can AI support us to find out what projects we should work on? And this is very interesting, I must say. So both from the outside-in perspective and also from the internal perspective, there's a very nice proverb in Germany. It's called, the Siemens company would know what Siemens company knows. So that's a little bit the issue behind it. The second point is just take a look at the planning phase. And maybe, in Germany, planning plays a good, important role. How could we support planning phases? By defining the right capacities, the right timeline, etc., especially if things are strongly changing in that VUCA world. I would just want to cite here one of an OEM manager or supply chain project manager, and he said, okay, if I got a new project, he was talking about a huge new plant, digital plant in southwestern Germany, and he said at the very beginning, I was asking 5 planners about how to conduct the planning, and he got 5 different results on whom I should rely on. And that is his wish to improve it for future. Execution, I think Gustav would like to emphasize both, because that was the most interesting point for those supply chain interview partners, saying, okay, there are all kinds of areas where we can use it. For example, for the as-is situation, especially in logistics, we got a lot of data to what are the parts to be delivered, what is the weight of the deliveries, etc. And there we could screen the data to find out the bugs in order to have a fine, transparent data line. And other things, for example, we had a project together with Bosch Power Tools talking about process mining to evaluate current processes. It was about the procure to purchase, procure to pay process in a Chinese plant. So there are a huge number of applications possible. And I will skip, I think, the next 2 slides. Monitoring, of course, on the one hand side, chatbots to improve communication and to discharge the project manager from daily work life issues. For example, okay, where may I find this? Where may I find that? And also to put a little bit the pressure on, okay, you need to realize measure 17 till next Monday latest. Otherwise, you will get out of time. Like I'm going to do at the moment. Closure I will skip just to find out the recommendations for future lessons learned. What should we do next in the sense of, okay, after the project is before the next project, what are here the hints to be kept in mind? And finally, let's come to the conclusion. We found out that the use in AI, so we've got a clear difference from the academic view and the practitioner's view regarding AI. And so we find out that it's still at the very beginning, even on the high level of high developed companies in high developed countries. And nevertheless, we got those practitioners see huge potential in using AI in supply chain project manager for future to get better results and to get them easier and in a smarter way. Future research, you see, we are only talking about the number of 14 experts. So that's quite not representative. That's quite clear. So we also have the lack of quantitative research and also research based on specific AI tools or based on AI specific supply chain management phases for focusing, for example, on the phase of the execution. So these are my final words. Thank you very much for your attention. And at the end of it, we're going to have some discussion. I would like to have
Now we can see the next presentation.
My presentation together with Gerd Moczek, who was my project leader about hydrochar from Vietnamese rice straw. And I did this work while I was working at Rostock University, at the same institution as Tommy Ender, who nicely explained the hydrothermal carbonization process. And I did this process with Vietnamese rice straw. Now I'm working at the University of Applied Science, Arts and in Hildesheim, Holzminden, Göttingen. And I used the Rostock templates because the work was done there. And but I have my affiliation now in the bottom line. So, and the next one is, the motivation for treating a rice straw with HTC. HTC is a wet process. And when you think about straw, you don't imagine that it would be wet and why to treat this. But in South Vietnam, we did this research together with the An Giang University in South Vietnam. Then they have 3 breeding seasons of paddy rice, and they have dry seasons from January to April, December to April, and rainy season from May to October. November is a bit of both. And the most of the paddy is harvested at the end of the summer season, almost 60%, and it is harvested mid in the rainy season. And then the straw contains between 20 and 30% of water. And for this wet material, hydrothermal carbonization might be a reasonable treatment option. Then you don't have to dry the straw before, for example, pyrolysis or other processes. And the goal of this investigation was to increase the knowledge about hydrochar from Vietnamese rice straw. There has been done before some work about Chinese rice straw. And in order to reach this goal, we used 2 varieties of rice straw, which were both harvested in South Vietnam, close to Long Xien in An Giang province. And we used the 2 varieties we could get. They were both harvested in the rainy season. And it turned out during the analysis that they differed greatly with respect to the ash content. The first variety, Lok Troy, contained almost 20% of ash. And the other variety, OM 5451, contained about 10% of ash. Otherwise, the composition was rather similar, apart from perhaps the hemicelluloses, where the lower ash content was compensated by higher celluloses in the OM 5541 variety. And to simplify the designation, we call them for rice straw high ash and rice straw low ash with the respective abbreviations. In the experiment, we tried, the straw was spray dried in Vietnam, then it was sent to Germany and further dried to about 7 to 8% water. And then it was causally chopped to stalk lengths between 20 and 20 millimeter, 22 and 20 millimeters. And the coarse chopping was chosen in order to find out how it would work, such that one could save milling costs and mills in a probable large-scale process. And the HTC experiments we carried out in the same apparatus as Tommy Ender showed before. Here it's open. It's a par 5423 with a 1 liter vessel and fixed head. And the materials, the suspension of the coarse rice straw and water, is filled into this cylinder. We filled 700 gram up with 7% straw and the remaining water, and then fixed it on the head and had the heating around and then carried out the experiments. We used in the experiments 3 temperatures, 200, 220, and 240 degrees Celsius, and 2 retentions time. 1 short, 2 hours, 45 minutes, and 1 long, 15 hours. And at 200 degrees, 2 hours, 45 minutes, it was a remainder from other experiments. We found by optical evaluation, we found out that there was very low carbonization, and therefore we only used the long retention time at 200 degrees Celsius. So I will show you the main results, some of the main results. This figure shows the approximative composition of the 2 varieties of rice straw with the yellow and the associated hydrochars. There, the hydrochars are named with the temperature, the retention time, and the abbreviation for the type of rice straw. On the left-hand side are the rice straw and hydrochars with high ash content, and on the right-hand side are the rice straw and the hydrochars with the low ash content. Here the gray represents the ash, the black the fixed carbon, and the yellow and orange represents the volatile organic matter. And the scale is the same for the amounts in the rice straw and in the hydrochars. They are presented on the same scale, such that you can see the development of the composition during the which has taken place during the HTC process. The first slide, you can see that the greatest changes have been done in the volatile organic matter, which is more and more dissoluted. The yield is represented by the ratio of the height of the bars for the hydrochar to the rice straw. So this scale shows the yield. And if you have a little bit roughly, the yield in total, apart from this at the highest temperature and retention time, from both types of rice straw, the hydrochar yields, they are rather similar. But if you look closer, they vary about 60 to 45, 40%. But if you look closer at the composition, then the compositions are rather different. At first, the hydrochar from low ash with high ash content also contains higher ash, and the hydrochar from the rice straw with a lower ash content contains higher fixed carbon. This is partly due to the higher respective contents in the respective rice straw. However, if you look closer, you also can see that were different mechanisms during the hydrothermal carbonization process, such when you look here at high ash, the amount of ash which is recovered from the rice straw during the hydrothermal carbonization process, it increases. These straw bars on the left-hand side, they become higher when the process temperature and the retention time increased. And this may be explained by the fact that you have rather high mineral content in the process water, and the mineral content is so high that at higher temperature, for example, calcium salts, they have reduced this solubility, and then they will precipitate on the hydrochar, such that the recovery of ash increases. However, in the hydrochars from rice straw with low ash content, the recovery of the ash decreased. You can see that this gray part of the bars becomes a little bit smaller because there the mineral content in the process water was not that high that the solubility products were exceeded, such that you got increased dissolution with increasing temperature and retention time. With the fixed carbon, it's the other way around. In the hydrochars with high ash content, on the left-hand side, if you see where you know all the bars, the black parts of the bars, they are a bit smaller than in the rice straw. So you really do not get net carbon fixation, which is one of the goals of hydrothermal carbonization. An explanation can be that there was the carbon fixation occurs that dissoluted organic compounds, they combine to new carbon and then precipitate on the rest of the carbon of the primary hydrochar. But if you have high mineral concentrations in the solution, then probably these soluble carbon products cannot meet and produce new hydrochar. This has been previously observed during hydrothermal carbonization of sewage sludge with high mineral content. Here, with rice straw with low ash content, you see that the black part of the bars in all hydrochars is bigger than in the rice straw. So here in these hydrochars, you will get a real carbon fixation, as intended by the hydrothermal carbonization process, because you don't have this destruction by high solubility, by high concentrations of mineral compounds. But at all, what you want is fixed carbon, and you can see that in both types of hydrochar, that there are very low differences in the amount of fixed carbon in the hydrochar, unregardable the operation conditions. It's rather independent. We got a maximum at the 220 degree 15 hours in both. It's a little bit, as Tommy Ender also get, 200 and some long retention time. But the differences were small, less than 11%. This might be interesting when you will when you activate these hydrochars to produce adsorption products, then you will get the same amount about. You will use this volatile in the activation process and just can decide whether you will want to have the losses in the gas or in the water. Yes. And you saw this, that you got real carbon fixation only in the hydrochar at low ash content. So to come to the conclusions.
Okay.
The ash content in VS nitro can vary greatly from variety to variety. So that and the composition of the hydrochar from rice straw strongly depends on the ash content of the rice straw, and that carbon fixation could not be achieved in the rice straw, could only be achieved in the rice straw with low ash content, but not in the rice straw with high ash content. So, thank you for your attention.
Now the session comes to an end. In Germany, with students and okay, something about circular economy in Germany or union and socialism. I skipped quite a lot. The problem is that we use a lot of materials, we have a lot of products, and we all call it waste if we don't use it at the end of the use. And that's why it is not possible to find one solution to solve all the problems we have. And how can we regulate it? What to do to end this problem? Circular economy works quite well in Germany, maybe in Europe, so we have a lot of differences between the member states of the European Union and also in all over Europe. In Germany, we have quite well or high recycling rates. Quite well is okay. But only 12% of the raw material is used in the European Union. And let's say the industry uses much more material than we get from the private households. Because industry counts we buy and throw away. The industry is thinking about money. Material brings high costs to companies, and that's why we try to recycle. Private people don't think about recycling normally. And the industry also has more and more cycles like reuse, repair, but we also will have in the future for private households, let's say. You know this, prevention at first and disposal at the last. We have to skip because of the time, some statistics, just to focus on the main field, construction and demolition waste, and mining and quarrying. Both together, you have more like 50%, and this is household waste. Normally it's between 10 and 50% worldwide. We only speak about household waste, and this is nothing. It makes no sense to speak about this from our focus, but we speak always about household waste. Just to show you where are other wastes we have to speak about, and we have to solve problems there. Recycling, what we have now, recycling quite well in Europe, in some countries more, in some countries less, the same with landfilling. Some countries more, like Germany, some countries less landfilling in Germany, some countries more. But even in Germany, we produce 400 million tons of waste per year, and 10% of the waste is still dumped. There's no solution for this waste, but the other 90% is treated or used. Recycling rates inside the European Union, it's quite well for paper, metal, and for glass. There normally not really problems, and you will find in some countries in central Germany higher recycling rates than this. Plastic packaging, and this numbers wrong, of course. A lot of numbers are not true, because inside this 40% is also incineration, because then you use the energy coming from the waste, and we think real recycling is material recycling. But we are on a good way. What's at the moment, what we are doing at the moment, maybe it's more interesting. We are on a higher stage in recycling waste management, and so than India or China. But I think we are not satisfied about this, because we can do much more. And that's why we became the plan of circular economy in 2015. And then since 2 years or 3 years, we have this circular economy action plan for the European Commission, and it ends in a European Green Deal. And there's a lot of things are involved in this Green Deal. Some are also for waste management. Now what we have to do, we should use or recycle more product. We should use it more times. Sorry for this. Maybe no. Sorry. There's always a discussion, do we need more plastic? I think we have to reduce also the plastic production because we can't handle plastic. There are some people saying we don't need plastic, but I don't want to be without plastic. What is happening with things and I think. And this is nonsense, but we have to handle it better. And we don't need so much plastic, and this is just an idea, just a dream, it's not the reality. And so we also have plans to recycle more and to reuse more of the recycled materials. So now we have to put in a new plastic product, 25% of us use plastic, and beginning from 2030, they have to put in 30% of old plastic, let's say old plastic. And recycling plastic is not so easy like metal because the material changes with behavior, and so it's not so easy to recycle. But this is not enough because at the moment we use 17% of our old plastic from new plastic products in Germany. This then we have a single-use plastic product ban. This is not zero waste. Even the name is nonsense. It's not possible. But this is banned in the European Union, and you will not find it a lot of packaging and nonsense plastic use. And what we now have to do is this. I think we should put ideal carbon caps. I don't know if you know, it shows one of the products. I haven't seen what we are into. You know, so that you can use the cap. And I think this is one of the problems with people use caps and then we don't have the cap. We have everywhere caps. Yesterday, my colleagues spoke about a lot of waste and plastic waste in the rivers and the oceans. And this is a huge problem worldwide, not really worldwide, but in the most places worldwide. And let's come to an end. What to do? Good ideas are the old ideas. I always ask old colleagues like thinking when they then how do you handle your water? Where comes your water from when you have been young? When we don't have, I don't have this thought when I was young. And I'm growing old, that means I have water when I was a child and without any plastic water. It is possible, I know it's easy, I have one, but we should try to repair more. And now we buy, throw it away, and that's over. We can't repair a lot of things. EPR is one of the, yesterday, another point explained what is EPR. Expanded producer responsibility. That means that if you produce something or you sell something, then you should be also responsible for the recycling, collection, and recycling. And so some money is coming in the system. This is one of the solutions that can work. We use it in Germany, and some of the countries use it. We try to prevent illegal waste exports, especially from the rich countries. And so we are fighting to reduce our exports, illegal exports of waste. We also import a lot of waste to Germany, especially public waste from our friend from everywhere, because we have the technologies in the plants, and so we can treat it in Germany. And we need more reusable systems. We know all this, but I don't think that we can do it in the next. And we are on the way. Some of the countries are reduce taxes when you repair or when you rent. We all know this. And now we get a packaging tax in Germany and in some other countries. So it will be more expensive to use packaging. And so we reduce the amount of packaging. And I think this is the last, beginning in 2024, next year. Carbon dioxide taxes are also starting with incineration plants. It makes it more expensive to incinerate waste. I think this is nonsense because what to do with the waste? We have to incinerate it. And I think this is not the best way, but we also need or we use taxes of carbon dioxide to reduce the emissions. We will have taxes on the fuel, also for transportation and collection of waste for the car, they do it. And there's a huge problem now. We constructed by our own, you don't know what it means, but construction and demolition waste also that we have more than 50,000 of all the waste in Germany of that kind of waste, and we had no regulations in the past. But there was a commitment between all the governments, the German government in the last 3 decades with the industry, solve the problem by yourself, and they did. And now the government brought in the regulation and nothing works. And so you can see here sometimes a differentiated country can be destroyed by a regulation. Just to say if it works well, please don't handle and let it go. I think. Okay, summary, waste management on a good way. We have huge differences inside the European Union, and we have to do more. And I think this is the main thing. We have, I think, more 15 years more time to handle all these problems, but we have problems for the next 100 years, and I don't think that we can handle it in a good way, but we will see. Okay, thank you very much. And let's say, more beautiful, only 200,000 have a good time. And like we say, this is enough for us. And not to go to a conference and meet 200,000 others. Okay, thank you very much. So, okay, now we can ask questions. So, now we have a question. He was the first, and then the lady. I want to mention yeah. I understand that AI is yeah. In your opinion, what would be your opinion for project management and supply chain management? How do you make say what about production management or use the data? What we have to solve this. What the your education how long you take to start it? And there is education for this was for this type okay, got it. Good. A good question because I think the question. I think you can do it within, I don't know, 16 hours minimum, just as a start. And then we just want to give an overview, or you have to focus on each part. For example, one of those AI tools could be process mining.
So even if you talk about process mining, we have a project that we have with force, power, they are management, and we do money, although the bus company says, okay, we have a good data code. I think every company tells me I was going for many years as a manager, and each time the counterpart says, no problem regarding data quality, they have it, and they never have those data. And even those highly qualified companies, they struggle with data quality. So this is one point, how depending on we would like to focus on some specific AI tools. But the second point is we put more on the business administration way or more on the technical way. I think this is also very important. That's quite different because if I think about those supply chain managers, they try to focus on application itself. Yeah. For them, it's more about they have to understand it. They have to have the ability to understand what's going on and what might be programmed by the colleagues coming from India. But nevertheless, it's some kind of workshop. But I think it's depending on the topic. But you see, even for those practitioners, they know a lot of project management, no doubt about it. They know a lot of things about supply chain management, but if you come to the detail, how can we apply AI? That's going to be difficult. And sometimes I think we can start at a low level and then climb up and come up. Okay. Thanks for the question.
Question is only, I'm and I was actually learned that in terms of because very more integrated entire supply chain and with AI you might need support from policy and policy.
Yeah, I think in general, if you talk about supply chain management, you see a lot of participants internally, externally. So it's even if you talk about the supply chain model, which is cross-border, it's difficult. And I think from the academic way, it would be the best way to go top down. That I fully agree. But in practice, I think we need those lighthouse projects. So I think to convince the others to do this job, I think we need those examples saying, okay, we know that they have a lot of work to be done, but afterwards we see, okay, there are no longer such bugs inside those data. So that's a wild group for me. Even if I'm a project manager in supply chain, we need to have always under pressure. Because supply chain managers are always in daily life, and especially in project management, they are under pressure. And I'm not quite sure to give any recommendations like that because I think we are not yet under pressure. We cannot go down. We need to optimize the last usage and we need to very because they know less type of water. Because I can do something. So even when we talk about actually we get the right people provide on this and for other. And it's fun for this side because they need our systems. And one system may be for one of our development systems. You can
we had all these systems to fill and refill and refill and refill. We had it in the past. Even Coca-Cola, you can remember these small bottles made out of glass, and all this is lost. And now we have plastic worldwide, no deposit solutions. We also have deposit solutions in Germany, but they are going down because it's easier to throw things away. We collect them in the bins, we don't throw it in the bottles. This is different, but it makes no sense to collect bottles, collect them, produce a new bottle, so it's better you can refill it. It's the same way like with care. And so he is right. This should be a better solution. To use it, collect it, or you use this kind of bottle to have access to drinking water, refill it by yourself, and tackle just the last way. And sometimes it doesn't work because we accept or we don't want to do without the bottle, and that's why taxes is just the last way. So it's right. We sometimes I think we have to, if we go back to the old methods we had. When we have from young, we had it everywhere. And then it's enough for this, and then what is the question you ask me once again? Because yesterday you asked because of the energy, and this is also an energy question. Or not. And one short and can't be everything. Okay, because of you, we when I don't know. If I knew this, when I would not be here. There is fossil fuels renewable. I think it will take a lot of time, but we will be able and we have to do it. Yes, it needs too much time, and I told you this is not my problem, but it will be your problem. We have to be faster, and we are not so fast. We don't have more than 100 build more. I don't know this. I'm very negative because I don't want to say what I think about this. Yes, but I will not say what I think about this problem. What is that? The plan is part 2, I think 2045. I think this is the plan where we try to reduce use of fossil fuels to zero. To zero, yes, we will see in the works. It's not easy because we always think about electricity, but electricity is not. We need heating, and we don't heat with electricity in Germany. We heat with gas or coal or whatever, or oil. And that's why I think we need 10 times more renewable electricity than we have now at home. And so it's not so easy. So then there are no more questions. Thank you very much. There should be a photo, a group photo against, yes, right. And then